Good morning. This week we are doing Unit 9. Unit 9 is an extension of Unit 7 and Unit 8. Unit 10 is as well when we get to that next week. Now, if you keep in mind, Unit 7, we were talking about atoms. Unit 8, we were talking about those electrons that were the valence shell electrons. And those valence shell electrons, well, we were talking about all the electrons in electron configuration, and the valence shell electrons are the ones that are clearly important as we continue. So keep in mind, we were talking about in Unit 7, the quantum mechanical model. Unit 8, we were talking about where those electrons are in those orbitals. Keep in mind, orbitals are areas of probability where electrons most likely are when they have a certain energy. Unit 9 now is going to be putting these things together into molecules, combining two or more atoms into these molecules. Bonding. We've talked earlier about several different kinds of bonding. We talked about ionic bonding, we talked about molecular bonding or covalent bonding, and we talked about, well, we didn't really talk about what we sort of understand, maybe you've had in past classes, metallic bonding. In this unit, we're going to talk about, and this goes back to the unit where we were doing naming. Critically, it's important to understand the difference where we delineate between ionic and molecular molecules because they're named differently. Now we need to start understanding what is going on to make these molecules different. And so this unit is an extension of the last one. We understand where those electrons are, and now we're going to see how different atoms interact. We're going to study some bonding models. There's a lot of bonding models out there. This week we're going to study, first of all, Lewis dot structures, another way of describing those valence electrons in an atom. A model a gentleman named Lewis came up with, and it's still, obviously this was a long time ago, but it's still what we use for many things, especially in organic chemistry. We're going to use this. And so obviously it's survived the test of time. It's a solid model. Now, interestingly, and there's a little piece in this week's unit, Lewis, Gilbert and Lewis, never won a Nobel Prize. Should his work have been awarded a Nobel Prize? Some scientists think so, because it has such lasting quality, and it's a fantastic model to explain so much of what we see. Why didn't he win a Nobel Prize? He was a jerk. He was not a nice guy. Other scientists did not like him. And it's a very interesting read, if you can read it in the additional information, about the controversy and how political Nobel Prizes are. You think they're science, you think they're peace, you think they're all these Nobel Prizes. They should not be political, but they clearly are. In any case, that's a sidelight, not a part of the objectives for this unit, but an interesting little piece of something to learn. In any case, we're going to learn the Lewis dot structures or dot structures to describe the valence electrons in atoms. So we're translating our electron configurations into a model, Lewis dot structures. We are then going to use that Lewis dot structure, and we've sort of used that when we were naming ionic compounds, so it'll be a little bit familiar to you. We're going to use that model to show graphically in a model how things bond. We're going to study VSEPR bonding theory, valence shell electron pair repulsion, which shows once they're bonded using the Lewis diagram or Lewis theory, we can see why they have a geometry. Molecules have a three-dimensional geometry, and that is, the form of them is critical to their function. Structure dictates function is a mantra that we really need to appreciate. And so we need to see, why do they have that structure? Why do they have that shape? Why do they have that three-dimensional form? So it's very important that we look at that, and that's what we're going to study in VSEPR theory. Then we're going to look at another theory called valence bond theory. Valence bond theory is also very important. It's an extension. It explains some things that VSEPR theory can't explain and help us understand out there in the world. There are many other models. One of them I'm just going to mention, we're not going to study it, is called molecular orbital theory, which goes beyond valence bond theory to understand it a little bit more. Not something we're going to learn in this course, though. So in any case, we're going to learn VSEPR theory for shape and structure and valence bond theory to understand a little more beyond the Lewis structure of this bonding. It's critically important to understand all three of these things and how they extend from Unit 7 and Unit 8 to understand what molecules look like. This will lead into what we're going to learn next week. In any case, let me check my notes here. We are also, interestingly, maybe not interesting to you, but it will be interesting. Another way to calculate heat of reaction. So when we have a molecule, obviously the attraction between the atoms is what holds them together. It's not really attraction between atoms. It's attraction between negatively charged electrons and positively charged nucleus. Keep in mind, everything is about this attraction. Those periodic properties, those periodic trends we learned, is all focused on attractions between those electrons and protons. If you don't completely see how it's related to attraction, we need to talk. You need to understand that. In any case, these bonding theories all rely on this attraction. And if you think about it, this goes back to Unit 7 when we talked about Bohr. In Bohr, we said, as the electrons go to a further higher energy level, the electrons have more energy. Maybe they've absorbed energy and gone from a lower energy state to a higher energy state. The electrons go away. Well, why is that? Well, because they're fighting the attraction between those electrons and those protons. In order to fight that attraction, you need to add energy to pull them apart. Again, attraction. And so attraction, once again, we have to think about this. That's what is the key to this bonding, is attraction. In ionic bonds, we say it's an electrostatic attraction. In a covalent bond, we say it's a mutual attraction to shared electrons. Mutual attraction of different nuclei to shared electrons, kind of the glue that holds them together. And so we need to understand that. Well, this also obviously involves energy. And so we're going to go back and we're going to learn something about bond energy. Bond energy is the energy required or involved in a bond. I'll let you discover that as you go. But the key to this is we can use these bond energies to once again go back to what we learned in Unit 6 and learn about heats of reaction, enthalpy of reaction, delta H of reaction. So we learned 3 ways originally how to calculate that or find it. Calorimetry experimentally, using heats of formation, or using Hess's law to add together different entire chemical reactions to get a heat of reaction. We're going to learn another way now involving bond energy. So this will be our 4th way to calculate heat of reaction. Now, different people present how to use this heat of reaction differently. I recommend do not start searching in YouTube because there's different ways to do it. But if you get them confused and put them together, they're clearly going to give you wrong answers. So stick to one model. One model is presented in our videos. And so you need to make sure I would follow that model to be sure you can use bond energies to calculate heat of reaction. We have a lab this week. It's a virtual lab. It's on paper and a computer. You're going to need to print out the document. You're going to need some kind of coloring device. Crayons, colored pencils work great. And follow the directions. In this lab, every time there is a italicized something, that's going to say that's a question you have to answer. There's procedures what to do using this computer program. It was actually developed at Illinois State University. It's fantastic. And it's going to show you visually on the computer these different shapes. But you need to make sure you complete it fully. Go in order. Don't skip things. Go in order. And when you get to something and tells you do it, do it. You're going to have to fill in these data tables. And in these data tables, I expect drawings of the models that you may see on the screen, and I expect them in color. So you're going to complete this and then turn it in assignments. At the same time, once you've turned that in assignments, a new set of videos will appear. But you cannot watch the end videos, valence bond theory videos, until you've completed this lab. So although everything is due on Sunday, you really need to have this lab done probably by about Wednesday or Thursday. It's going to take you a fair amount of time, not like millions of hours, but it's going to take you some time. Do it patiently because it's really a teaching tool that's going to teach you VSEPR theory along with the videos. So you're going to watch the videos first, do the lab, and then look at the valence bond theory, which is a new theory. But again, those videos will become available to you once you've turned in the lab. So don't wait till Sunday to do the lab. Your other assignment this week is going to be a mastering chemistry. So really all you have to do, I'm sure to say that. So what's expected this week is the lab, which hopefully will come in early in the week, and the mastering chemistry. We'll continue this concept more next week in Unit 10, and there will be another exam after Unit 9 and 10. Now, as I explained, I think I explained, maybe it didn't make sense. The Unit 9, 10 exam will actually cover Units 7, 8, 9, and 10. The thing you did, for yesterday was kind of a tool for you to use. I don't completely understand that yet, or I do completely understand that. It's a preview of some of the material that you have to master to really do well at Unit 9 and 10, and then you'll be assessed on Units 7, 8, 9, and 10, all in one assessment. So you're going to be seeing that stuff again. So if there's any questions and you don't understand some of the concepts, be sure you either reach out to me or find out the answers to those, to make sure your understanding is complete. Because once again, you're going to have that understanding to understand this week, and you're going to be assessed on it again on our next exam, which will be at the end of next week. And that's this week's stuff. So please, if you have any questions about content of either the last 2 weeks or stuff this week, or if you have questions about how to complete the lab or questions about the Mastering Chemistry, I hope you will reach out to me so we can figure it out together. Okay, that's Unit 9.